We're going to be looking at Chapter 10 from the Management Information Systems text. This chapter covers decision support systems and expert systems. Organizations are highly dependent on their employees making smart, efficient, and effective decisions in order to earn profits. Computer-based systems can be beneficial in this process because there is usually large amounts of information that need to go through intensive processing in order to be summarized and put in a format that is conducive for the employees to use it for those decisions. Applications today are oftentimes combinations of both types of the decision support aid systems that we have, decision support systems and expert systems. These systems often utilize databases, data warehouses often, and sometimes online processing application technologies, OLAP, to enhance the ability to use this large quantity of data to make the decisions. Our decision support modules are oftentimes part of a larger enterprise application, and oftentimes these applications are called business intelligence tools or BI tools. Some of the application systems that our decision support systems can be a part of include the customer relationship management system, the enterprise resource planning system, and the supply chain management system. And we've already talked about these in prior chapters, but just a quick reminder. The customer relationship management system is technology that allows companies to manage the interaction with their customers and the potential customers. So they're tracking the communication they have. If there are complaints, they are keeping track of all that information so they can make sure those issues get resolved and they don't lose their customers. The ERP system, Enterprise Resource Planning systems, support decision-making around areas such as production capacity planning, logistics, and inventory replenishment. Supply chain management systems are centralized management tools that allow us to control the entire flow of goods and service, including all processes that transform our raw materials into finished goods. By managing these flows, we can reduce costs and speed up the delivery to our customers. One thing we need to be aware of is our decision support systems that we are talking about in this chapter are oftentimes using the databases and or data warehouses that are being utilized by these other systems in our organization. So the CRMs, ERPs, and SCMs create the data in the databases, and our decision support systems are using those. So when we first look at decision support systems, it's good to understand the types of decisions and problems that we will be dealing with. So whenever there is more than one option, we need to make a decision to determine what we want to do. A decision is easy to make when there is clearly one option that is going to have a better outcome than the other. But oftentimes decisions are more difficult because several alternatives seem reasonable and look like they will produce a positive outcome. In business, there can be dozens or hundreds of these types of decisions or these types of options that would give us a desired result. And the problem becomes trying to decide which is the best alternative. This is why problem solving and decision making are closely related. The decision making process consists of 3 phases. First is the intelligence phase, where we are collecting facts, beliefs, ideas. We're collecting data both inside and outside the organization. And we're trying to collect as much information as possible on the ways that we could solve the problem we are working on. The second phase is the design phase. And in the design phase, we will be looking at the method for considering the data. It could be a sequence of steps, formulas, or models, or other tools that will help us organize the data and put it into a way that will lead us to an alternative that's going to be better. Sometimes we use things like charts so that we can see trends and things like that to help us organize the data and get it into a format or a model that will allow us to make a decision from it. And then the third phase is the selection or the choice phase. In this phase, we will be reducing the number of alternatives. If someone else is the decision maker, we would be presenting them with a list of alternatives that we have ranked in the order that we would place them. And if we are the actual decision maker, then we would be making the choice of what we think is the most promising option. After the choice phase, the business would then implement the course of actions based on that alternative. Businesses collect data from many sources. They collect it internally from within their organization by processing all of the transactions that flow through their business, utilizing those systems that we discussed earlier. They capture a lot of data about their customers, data about the products they're selling, the material that goes into it, their suppliers, and so forth. They also collect data from external sources. Perhaps there are industry groups that they can pull information in about how other businesses are handling situations in their industry. And then businesses use models to analyze the data. So a model is an abstraction of that reality. So we could have maps to represent geographical data like we saw with our 3D map in Excel. We could have numbers going onto charts and adding a linear trend line to analyze that data. But somehow we are turning that business model into something that will help us determine the path to take. Problems are one of 3 kinds. We have structured problems. This is a problem where there is an optimal solution, and we can reach that optimal solution through a single set of steps. Since we can easily determine the set of steps and the sequence to follow, structured problems are fairly easy to resolve. Usually, mathematicians call this sequence of steps an algorithm, and the categories make it easier to follow these. Many business problems are not structured problems because there's too many possible scenarios that we could go through. Unstructured problems are ones where there is no algorithm to follow to reach an optimal solution. Either there's not enough information about the factors that might affect the solution, or because there are so many possible factors that we cannot figure out an algorithm to guarantee an optimal solution. So an unstructured situation is closely related to uncertainty. So they give you some examples in the book, and we'll look at a few of those in a second. The semi-structured problems are ones that are neither fully structured nor totally unstructured. So there could be multiple solutions that we could find for these problems. And business professionals encountered semi-structured problems almost every day in many different industries and in many different business functions. So the goal is to choose one goal that will bring about the best outcome, but keeping in mind that there are probably a lot of alternatives that would bring a positive outcome. So then it becomes trying to find the best one. So here are some examples of structured and unstructured problems. And this is also in your text. So you can see we've got semi-structured problems of what are the benefits of opening an office in France. There could be a lot of benefits. We could look at other office locations. We could look at maybe partnering with a company in Paris instead of actually opening an office there. So there are a lot of options that we could consider, and we have to try to figure out the best one. Which stock will yield the highest return by the end of the year? That's another example of a semi-structured problem because there are so many variables that could fall into that solution. A decision support system is a computer-based information system. It's designed to help knowledge workers select one of the many alternative solutions for their problems. So it's hopefully designed to allow us a way to take the data that we have, consolidate it and combine it to look for trends and patterns, and then come up with the best solution for the company. So these can help us increase market share, reduce costs, increase profitability, enhance product quality. So for example, I could be looking at if I replaced one of my component parts with a different part, would that make my machine run better or last longer? And those types of quality issues could be considered as well. A lot of this analysis could probably be done individually by employees or managers, but it would be very time consuming and would often take too long and would result in bad decisions because we wouldn't have the time to get the analysis we needed to make the decisions in a timely fashion. Although the use of decision support systems typically increases with the level of management as companies or as individuals move up in their organizations, the systems are used at all levels of the organization. We can see we have another keyword here for decision support systems. So again, if you look at the PowerPoint that is available in Canvas, all of the keywords are also defined in the notes of the PowerPoints. So if you download that PowerPoint and open it up in the PowerPoint software, you will see the keywords defined there as well as in your text. The three components of a decision support system include the data management model, sometimes called the database management module, the model management module, and the dialog module. Together, these three modules help users to enter a request and in a convenient manner, search through vast amounts of data to focus on the relevant facts, and then process the data through desired modules and models, and then present those results in one or several formats so that they can be understood by the end user. The first module is the data management module or the database management module. This normally consists of a database or data warehouse that provides data for the intelligence phase of decision making. Some of that data may have been collected internally by processing transactions through the normal day-to-day business, and other pieces of data could be gathered through other forms of data capturing. Perhaps we have systems built into our websites to track the information about our customers and what they're analyzing and things like that, what they're looking at. The database management model or the data management model accesses the data and then provides a means for the decision support systems to select data based on the criteria specified by the individual requesting the information. You want to remember that a database is a collection of data generally stored and accessed from a computer system. Where databases are more complex, they are often developed using formal design and modeling techniques. So the decision support system is going to use the database or the data warehouse, but it can also be linked to databases that are used in other systems like your ERP, SCM, and CRM systems. Companies may prefer their decision support systems to actually access their data warehouse rather than the transactional database that they use on a day-to-day basis. The data warehouse typically has substantially more historical data available in it than the normal day-to-day transactional database would give them access to, and so that would give them a longer time period or a larger geographical area, for example, to study in order to determine the answers they're looking for. The model management module is used to turn data into useful information. It utilizes some form of a business model. It could be a single fixed model or a dynamically modified one, or a collection of models that the user selects the most appropriate one. A single fixed model is a fixed variable model that does not change. A dynamically modified model is automatically adjusted based on the changing relationships between the variables. So it's often some sort of a mathematical research that is putting the data in a form that allows us to predict from it. We saw some examples of these models. For example, we worked with the forecast sheet in Excel, and we also worked with trend lines when we were charting our data. These are examples of models that could be used to help predict future outcomes. The model management module could have patterns that are unique to the industry. So you'd want to be careful to make sure you are using the correct pattern or model based on the industry you are working with. But these models are going to try to describe the relationship between more than one variable. And sometimes we have to simulate physical environments within this to determine the outcome. So we may need to simulate, for example, if our product is normally used in water, then we would need to simulate what would happen to it if it was underwater for large periods of time, or things like that. One model that we could use and is commonly used is the linear regression model. This is the best fit linear relationship between 2 points. So we saw this when we looked at our trend lines in Excel charting. It's not always a straight line as we saw with our trend lines. It could be a logarithmic pattern or some other pattern than just a regular straight line. But the regression, a linear regression model does help us predict future outcomes. And this shows you another example of a trend line. Now the system must provide an easy way for users to interact with the program, and the part of the DSS that allows the users to interact is called the Dialog Module. It prompts the user to select a model, allowing the user to access the database and select the data for the decision process, or set criteria for selecting the data. So it gives them a way to interact with the data, choose the data they want, and maybe choose the module or the models that they want to work with as well. Sometimes these are set up as commands or pull-down menus. They could be icons, dialog boxes, or some other user interface approach. It's not much different than the user interface for other types of applications. And as an increasing number of decision support systems become available through use on the internet, some of these dialog modules are especially designed to be compatible with web browsers. The dialog module is also responsible for displaying the results of the analysis so that we can interpret that and make our decision. So this gives you an example of what a dialog module could look like, allowing us to put in, for example, the amount of money we're going to spend, the expected sales, and some other information, and then it would come back with our results. With sensitivity analysis, we already looked at this a little bit with Excel. It's also sometimes called what-if analysis. It allows us to test the degree to which the profits grow or shrink if one or more of the factors that affect it are changed. So for example, if I were to look at, let's say, Coke and I made a price change and I added $1 or doubled the price of every can of Coke, you would expect to see a significant change in sales because the sensitivity of a product like Coke with a lot of competitors, the sensitivity of that to a price change would likely lead to people buying a different product. Now, if you compared that same sensitivity of a price change perhaps to a rare medical treatment that you had to have to survive, if they increased the price of that medical treatment and it was the only option you had, you would find a way to try to pay that higher price. And so it would not have the same sensitivity in the quantity of sales to a price change that something like Coke would. And that's what we're referring to with sensitivity analysis. We can have decision support systems perform sensitivity analysis on multiple parameters at the same time. And so that can really help companies analyze what changes to make in their businesses. We can utilize decision support systems to look at a lot of different variables, and spreadsheets are an excellent tool, as we saw with the what if analysis that we utilized in Module 10 of Excel. Spreadsheets can be used to enter both data and formulas, and we can utilize models and forecasting in trend lines and other things once that data is in there. Spreadsheets therefore make an excellent tool for both data and models that the decision support systems need, and they are a great tool for building decision support software. We can look at the sensitivity analysis by changing data in one or more cells and seeing what the impact on the overall answer is from those changes. You can see some of the ways that we can utilize decision support systems. For example, tax software such as TurboTax have tax helper applications that will help a user of their product look at some of the other activities in their life that may allow them to save money on their taxes. It'll ask you questions like, did you own a home? And then it'll also give you advice at the end of your tax return, telling you things that you could do next year potentially that would help you save money on your taxes. Yield management or revenue management is a product that helps us maximize the revenue from certain industries. For example, the airline. How do I maximize the revenue for an airline trip? It often results in price discrimination, which is legal and common practice in the airline industries. You may pay a different price depending on how far in advance you purchase that ticket. Some companies offer decision support systems specifically designed to analyze shoppers' behavior based on captured data such as the pages that they viewed, options that were clicked on, and sequences of pages that the shoppers viewed. So these click streams are sometimes also utilized in order to analyze these decision support systems. Sometimes these decision support systems do lead to ethical issues. For example, in the financial services, they often utilize decision support systems to help determine whether or not to grant credit to a customer. If there are errors in that individual's personal data in the data being used for those decisions, then someone could be denied credit that actually would be a good candidate and should get it. The other type of support systems are called expert systems. These systems are developed to emulate the knowledge of an expert to solve problems and make decisions in a relatively narrow domain. A domain is a specific area of knowledge. For example, these are used a lot in medicine. I've seen them used in legal issues as well. So the purpose of the expert system is to replicate the unstructured and undocumented knowledge of the few, the experts, and put it available to many other people who need the knowledge but do not have that same level of expertise. Expert systems are part of the artificial intelligence area of technology, and they often try to focus in on emulating how humans learn and how we solve problems. An expert system is required when it is not possible to get access to the expertise of the individual. You'll notice on this particular slide there are a lot of different key words, so please make sure you study these topics. Expert systems are often based off of a knowledge base. So a knowledge base is a collection of facts and the relationships between them. They use something called an inference engine. The inference engine is software that combines the data that is input by the user with the data relationships that are stored in the knowledge base and results in a diagnosis or the suggestion for the best course of action. In most expert systems, the knowledge base is built with a series of if-then rules. So if you go into a medical expert system, for example, it may say, does this person have a headache? And if the answer is yes, then the next question might be, do they also have a fever? And then the next question is going to ask for another symptom, and it takes you down a path based on the answers that you come up with. Neural networks are also used in some. Neural networks are computer programs that emulate the way the human brain works and learns, and they can learn from new situations and formulate new rules in the knowledge base to address events that were not originally considered in their development. So they are more sophisticated than a simple if-then set of data in the knowledge. So for example, if you took that same medical example and you wanted to add a neural network concept to it, if it was learning what the new benefits from this new coronavirus, what were the new symptoms of that, and it would automatically, as this was building and we were learning more information, it would be adding new answers and new solutions in that if-then rules to lead you down the path of whether you needed to seek treatment or not. Case-based reasoning is a methodology for solving new problems based on the solutions of similar problems or cases that we've seen before. The important parameters of the case are analyzed to find cases that appear similar, and then it tries to analyze based on those similar cases and lead you down a path of what you should most likely do. The knowledge base in case-based reasoning tools is a database of cases so that it can look from the archival of cases and try to find similarities between the case we currently have and those that were looked at before. So this shows you the relationship between the knowledge base, the dialogue module, and the inference engine, eventually leading to the output that the individual receives for the optimal decision of an expert system. We've talked about a few uses for these, but we've seen them in medical situations where, it can help doctors with diagnoses, or many people try to get into some of these expert systems that they can utilize to try to self-diagnose or determine if they need to go see a doctor. We can use them for credit approvals and credit evaluations. They are also sometimes used to detect fraud. So, for example, with insider trading. Insider trading is a way of trading stocks based on information that is not available to the general public. It's only available to key people within the company. And that is a serious breach in U.S. federal law if you do that. So the American Stock Exchange has expert systems in place that look for those relationships to help determine if security transactions should be reviewed or not for insider trading. And so they utilize these to help them prevent fraud. Not only can it detect the fraud when it happens, or helps detect the fraud, but it also deters some people from considering committing the frauds because they know these tools are in place and they could get caught. So group decision support systems are things that we talked about when we were looking at collaboration. When a team of people need to make decisions, they can utilize these group decision support systems. They're sometimes called collaborative systems or group intelligence. They facilitate contributing of ideas and brainstorming between all of the individuals so that hopefully as we're all putting in ideas and we're all contributing, then we vote on a decision and we end up with a much better decision and a better outcome than had each of us tried to do it on our own. We also have geographic information systems. These can be map related that we can use for decision making if it has a geographical component or a location component to our data. We saw an example of this when we did our 3D map in Excel in module 11, I believe it was. That allowed us to see where the sales were happening geographically and then also by store. So as a business, we could try to figure out what is leading to one store's performance being better than another's. So these geographic information systems typically consist of a database of quantitative and qualitative data, a database of maps, and a program that displays the information on the maps. So oftentimes we have digitized maps that are being produced from satellite images or aerial photography, and they can be used. We've also seen cars driving around for Google Maps in our area and Google Earth, where they're taking pictures as they're driving around town, and their car has a special camera on the top of it, and you see them driving around on all the roads trying to map and document that information for use in these geographical information systems. So some of the web technology that has helped utilize some of these geographic information systems include companies like Google Earth, MapQuest, Yahoo Maps, Google Maps, several others. They are utilizing HTML and XML that support the presentation of the marked up maps. So HTML and XML are the primary languages used to compose and retrieve the web pages that support the presentation of the pictures with the marked up areas. This makes them ideal for retrieval for the marked up maps. You can use these to figure out bus routes, to figure out perhaps delivery schedules for your truck drivers. City planning use these. So you can see that there are a lot of uses for these in practice, trying to determine the most effective places to put your ATM machines or where to locate outdoor recreation sites, things like that. Some of the other things that we need to be aware of is the HTTP Hypertext Transfer Protocol. That is the communication protocol used to connect the web servers on the internet. Its function is to establish the connection with the server and send the HTML pages back to the user's browser. The HTML is the language that is composed and making up the web pages themselves. Multimedia, we saw that as one of our key terms here. Multimedia is the field concerned with computer-controlled integration of text, graphics, drawing, and images, still and moving. Could be animation and also audio. Clicking different areas on a map and having that zoom in and out as well as bring up related information in the form of other maps or text is utilizing the multimedia capabilities of the internet and the web. Mashups is another term that we have, and that is the application. That is where we take applications and we combine features of two or more applications into one. Often one of these applications shows maps. Combining the maps with data such as the location of certain information, events, clubs, and real estate creates a specialized graphic information system. We've seen this combination of things when we deal with looking at Google Maps. If you click on Google Maps, you now are able to see where different restaurants are that are near you. You're able to see different individuals, locations, as far as if you've got friends. Sometimes you can see where they are, if they're utilizing those same tools. I've also seen tools that allow us to see Waze is another one where we can actually see where other drivers have notified that there are police maybe, or where there are accidents coming up, and you can alerted to those possible threats to your trip, utilizing these mashups of combining multiple applications into one. That concludes Chapter 10 from the Management Information Systems text.